The map of our world is about to change. I'm talking about the continent of Africa splitting into two.
Africa is undergoing a transformation that could change the map of the world forever. Beneath the surface of East Africa, the Earth's crust is tearing apart as the Somali and Nubian tectonic plates drift away from each other. This slow but unstoppable process is creating a massive rift that experts predict.
It's being predicted now. An entirely new ocean could emerge in the African continent.
Will one day give birth to an entirely new ocean. The thought of an ocean forming within the continent is both fascinating and terrifying. What does this mean for Africa and the world? Let's dive into this jaw-dropping phenomenon. Dabahu volcano. In September 2005, the ground beneath the Afar Depression in Ethiopia stirred with incredible force, marking the start of a natural event unlike anything seen before. This remote region experienced a wave of earthquakes, more than 130 in just 1 week. These weren't mild tremors, they were powerful jolts that rattled the earth and left local communities stunned. For the people living there, who had no prior warning, it felt like the land had suddenly turned against them. The ground shook almost non-stop as if something massive was stirring deep beneath their feet. What was happening beneath the surface was nothing short of extraordinary. The Earth's crust was pulling apart. Tectonic plates, the massive slabs of rock that make up the planet's outer shell, were drifting away from each other. As they separated, magma surged upwards through the cracks, forcing its way toward the surface. Scientists monitoring the region quickly realized this wasn't just another series of quakes. It was the prelude to a rare and dramatic geological event. Then on September 26, 2005, the Dabahu volcano erupted. Molten rock, ash, and gas burst into the air as magma forced its way to the surface. Although the eruption wasn't explosive by global standards, its impact was monumental. It left behind enormous fissures, deep cracks in the earth so large they could be seen with the naked eye. These fissures stretched across 37 miles of the landscape, splitting the ground apart in ways that seemed almost unreal. For the 6,300 people living nearby, the eruption was a disaster. Entire families had to flee as their homes became unsafe. The land they relied on for farming and grazing livestock was destroyed. Livestock, which many depended on for survival, died in large numbers, leaving communities without food or income. As if that wasn't enough, access to clean water became a major challenge, and relief efforts struggled to reach the most affected areas. It was a moment of chaos and hardship for the people of the Afar Depression. But while the human impact was devastating, the scientific significance of the event was groundbreaking. The eruption gave geologists and seismologists a rare chance to observe Earth's tectonic processes in real time. Normally, the movement of tectonic plates and the formation of rifts take millions of years, far too slow for humans to witness. But in the Afar Depression, this process unfolded over mere days and weeks. It was as if the Earth had sped up its clock, giving scientists a front-row seat to watch the formation of a new ocean. The Dabahu eruption marked the beginning of a rift, a massive split in the Earth's crust that will eventually lead to the formation of a sea. Satellite images and GPS data revealed just how dramatic the changes were. Large sections of land shifted by several meters in just a few days, creating deep fissures that exposed molten rock and intense thermal activity. This was caused by the Somali and Nubian tectonic plates pulling away from each other. As they separated, the thin crust above them fractured, creating pathways for magma to rise and widen the rift. For scientists, this event wasn't just fascinating, it was a treasure trove of information. By studying the Dabahu eruption, they gained insights into how ancient landmasses like Pangaea might have split apart millions of years ago. It also provided a vivid example of how new oceans form, something that will continue to reshape Africa's geography over the next millennia. The Afar Depression is unique because it sits at the intersection of three tectonic plates, making it a hotbed for geological activity. The Dabahu eruption proved that Africa's rifting isn't just a distant theory, it's happening right now, and it's reshaping the continent in ways we can see with our own eyes. So how does the East African Rift work? Let's find out. Exploring the East African Rift. The East African Rift is one of the most fascinating and dramatic features of our planet's surface. Stretching about 3,000 kilometers, it begins in the Afar Depression in Ethiopia and extends southward through Kenya, Tanzania, and Mozambique. But this isn't just a line on the map, It's a living, evolving landscape where the Earth's crust is tearing itself apart. This rift is the boundary between two massive tectonic plates, the Somali plate, which is moving southeast, and the Nubian plate, which is drifting northwest. The driving force behind this incredible transformation is magma, the molten rock beneath the Earth's surface. Deep below the rift, magma rises from the mantle, building pressure that pushes the two tectonic plates further apart. As the plates drift, the crust in the rift becomes thinner and weaker, creating cracks, fissures, and fault lines. When magma forces its way into these cracks, it cools and hardens, forming a new crust. This creates a continuous cycle. Old crust is destroyed and new crust is formed, making the East African Rift a kind of land factory. This process is similar to what happens at mid-ocean ridges, where new ocean floors are created, but here it's happening on land. But magma isn't the only force at work. Gravity also plays a huge role. As the rift expands, enormous sections of the crust sink under their weight, forming cliffs and deep valleys. These valleys often fill with water, creating some of Africa's most famous lakes, like Lake Tanganyika and Lake Malawi, which trace the path of the rift. The result is an incredibly diverse landscape, with active volcanoes, bubbling hot springs, and fertile soil that supports life in many forms. In the distant future, the rift will widen so much that seawater will flood in, likely from the Red Sea or the Indian Ocean. When this happens, the African continent will split in two, and a new ocean will form between the eastern part of Africa and the rest of the continent. This isn't just a theory, it's an inevitable outcome based on the science of plate tectonics. Similar events have happened before, such as when the supercontinent Pangaea broke apart around 180 million years ago. Millions of years ago, the Atlantic Ocean began to take shape when immense tectonic plates pulled apart, breaking up land masses that would eventually become the continents of Africa and South America. Today, a similar process is unfolding in East Africa, where the East African Rift is slowly tearing the continent apart. While this process is on a much smaller scale right now, its outcome will be just as dramatic. Over tens of millions of years, a new ocean will form, completely transforming the region's landscape and the global map as we know it. This transformation has already begun. In some parts of the rift, such as the Afar Depression in Ethiopia, the land has sunk below sea level due to the movement of magma beneath the surface. This process of land subsidence is ongoing, and satellite data reveals that the rift is steadily widening by a few millimeters every year. Though this movement seems minor, over geological timescales, it will drastically change the face of Africa. Eventually, the rift will open wide enough for seawater to flood in, creating a brand new ocean. When that happens, Africa will split into two distinct land masses with coastlines framing this newborn ocean. This monumental change will not just reshape the geography of the region, it will bring dramatic environmental and ecological shifts as well. Coastal ecosystems will develop where there were once valleys and plains, fostering new marine habitats and biodiversity. However, this change will also create enormous challenges for the people living in the region. In areas like the Afar Depression, where fertile land and lakes provide food and livelihoods for local communities, the encroaching ocean will likely force thousands to relocate. Farmlands could be lost, and freshwater sources could disappear, disrupting lives in ways that are hard to imagine. Adding to these challenges, volcanic activity in the region is expected to intensify. As the rift grows and magma continues to rise to the surface, more eruptions could threaten nearby communities. The shifting geology may even alter the region's climate, potentially changing wind patterns, rainfall levels, and access to fresh water, factors that are crucial for sustaining both human and animal life. The forces driving the rift. At the core of the dramatic changes happening in the East African Rift is the slow but unstoppable movement of the Earth's tectonic plates. The Nubian plate, which makes up most of the African continent, and the Somali plate, which forms its southeastern part, are slowly drifting apart at a rate of up to 2 inches per year. While this might seem insignificant on a human timescale, this gradual separation adds up over millions of years, leading to huge changes in the Earth's crust. This movement is powered by convection currents deep inside the Earth's mantle. The heat from the Earth's core causes the molten rock to circulate, creating enough force to break apart the crust above. This forms a divergent boundary between the Nubian and Somali plates. Unlike places where plates collide and form mountains, This type of boundary tears the surface apart, creating new landforms. The East African Rift is like a land version of what happens at the world's mid-ocean ridges, like the Mid-Atlantic Ridge. As the plates move apart, magma rises from the mantle to fill the gap. When it cools, it forms a new crust. Over time, this continuous process will widen the rift, eventually leading to the creation of a full ocean. The mechanism is both simple and powerful. As magma pushes up, it weakens the Earth's outer shell, causing it to crack and thin. These cracks turn into fault lines and fissures, forming steep valleys and cliffs within the rift. Places like the Afar Depression show how active magma can create visible features, like basaltic plateaus and volcanic cones. This process of crust creation isn't new. Around 180 million years ago, a similar boundary opened between what are now the South American and African continents, leading to the formation of the Atlantic Ocean. The East African Rift offers a rare chance to witness this dramatic change happening on land, not just beneath the ocean. The region isn't just a geological wonder, it's also a place of constant activity. Earthquakes and volcanic eruptions remind us of the immense forces working beneath the surface. The stress from the plates pulling apart causes frequent tremors, and some, like the 2005 Daba'a event, result in hundreds of earthquakes over a short period. This shows how quickly these forces can change the landscape. Volcanic activity is just as intense, with some of the world's most active volcanoes in this area, like Erta Ele in Ethiopia and Oldonyo Lengai in Tanzania. These volcanoes not only release enormous amounts of magma, but also reshape the landscape, adding new layers of volcanic rock. The magma chambers below them further weaken the crust, speeding up the rifting process. One striking feature of the rift is the geothermal activity, such as hot springs and geysers, where heated groundwater bursts through to the surface. These areas show just how close the magma is to the Earth's crust. Over time, the combination of plate movement, magma rising, and frequent earthquakes will eventually form a new ocean basin. As the Somali plate continues to drift away from the Nubian plate, water from the Red Sea and the Indian Ocean will fill the widening gap. The result will be a new ocean, with regions like the Afar Depression already sitting below sea level. Cracks in the crust allow magma and groundwater to interact, creating temporary lakes of boiling mud or lava. In the future, these will become permanent bodies of water, marking the birth of a new ocean. The forces driving the East African Rift are deeply connected. Plate movement starts the process, but it's the magma rising the earthquakes and the shifting crust that makes the rift an active and ever-changing region. This powerful display of geological forces shows how delicate the balance is between the Earth's inner workings and the changes happening on the surface. The rift creates both challenges and opportunities for life in the region. Understanding the mechanics behind this process helps us realize just how massive the changes are. However, these natural forces aren't working alone. Their impact spreads into the lives of the people living in the rift region. This brings up the next issue. How will these communities adjust to an environment that is always changing because of the Earth's constant movement? And how will all of this take place? Let's explore further. Phases of ocean formation. The creation of a new ocean in the East African Rift is a gradual process that turns dry, landlocked land into a massive body of water. The movement of tectonic plates drives this transformation. The Somali plate and the Nubian plate that are slowly pulling apart. The process happens in 3 clear stages, each one marking a major change in the landscape. The first stage is the rift to valley. This begins when the tectonic plates start to separate, causing cracks and faults to appear in the Earth's crust. As the plates move apart, magma rises from deep within the Earth, causing volcanic eruptions and earthquakes that reshape the land. Over time, these forces deepen and widen the rift, creating a long, narrow valley surrounded by cliffs. Next comes the valley to Gulf stage. As the rift continues to widen and sink, parts of it dip below sea level. Water from nearby seas or oceans, such as the Red Sea or the Indian Ocean, starts to flow into these low-lying areas. This water gradually forms isolated gulfs and narrow channels. In places like the Afar Depression, some areas are already below sea level, showing the first signs of water starting to flood in. Finally, the Gulf to Ocean Basin stage takes place. Over millions of years, the gap between the plates continues to grow wider, turning the Gulf into a huge ocean basin. magma keeps rising to form a new ocean floor, and the tectonic activity keeps the boundary between the plates active, making the ocean even larger. At this point, the rift's geology starts to resemble that of established mid-ocean ridges. Slowly, the area begins to transform into a full ocean. But the real question is, when will this incredible transformation happen? Let's take a closer look. The estimated timeline. The East African Rift offers a rare opportunity to see the beginning stages of ocean formation, although it seems almost frozen when viewed over short periods. Scientists believe a fully formed ocean could appear in about 5 to 10 million years, with the rift widening about 2 inches per year. However, geological events could speed up or slow down this process. In comparison, the Atlantic Ocean took tens of millions of years to form after the supercontinent Pangaea split. The East African Rift is following a similar path. As the Somali Plate separates from the African continent, a new island made up of parts of Ethiopia, Somalia, and Djibouti will form along the rift's eastern edge, surrounded by the new ocean, similar to how Madagascar separated from Africa millions of years ago. The coastline of countries like Kenya, Tanzania, and Ethiopia will also change as the ocean forms, affecting ecosystems and human settlements. Over time, this new geography will influence the region's biodiversity and resource distribution, playing a key role in Earth's evolution. Though the rift is still in its early stages, it is laying the groundwork for a major geological and environmental change, just like past events in Earth's history. To understand the future of the East African Rift, we can look to similar events in the past. Around 30 million years ago, the Arabian Plate began to separate from Africa, forming the Red Sea through volcanic activity and seismic events. The rift slowly widened and a new oceanic crust formed. Today, the Red Sea is an example of a rift that has become an ocean basin, which is what we can expect for East Africa. Around 200 million years ago, the supercontinent Pangaea began to break apart, leading to the formation of the Atlantic Ocean. This ancient process shows that East Africa could eventually host a large ocean that will dramatically change the continent and global geography. Both the Red Sea and the Atlantic Ocean weren't always as we know them now. They were formed through major geological events. These events have major effects on ecosystems, biodiversity, and climate. When continents split or rifts turn into oceans, ecosystems change, and biodiversity can grow as species evolve in isolated areas. For example, Madagascar's unique plants and animals evolved after it separated from Africa. As seawater enters the rift zone, new marine ecosystems form, from coral reefs to deep-sea trenches. Over time, the climate along the coast may become wetter and cooler, while inland areas could become drier. These changes could affect agriculture and ecosystems in the region. Geological events like the formation of new oceans often drive climate changes. For instance, about 2.8 million years ago, the rise of the Isthmus of Panama cut off direct flow between the Atlantic and Pacific Oceans, affecting global climate and triggering ice ages in the Northern Hemisphere. As East Africa's ocean develops, it may shift sea and wind currents, changing the region's climate and impacting agricultural practices and ecosystems. Technology plays a key role in studying and tracking the East African Rift's progress. Scientists use satellites, seismic instruments, and advanced models to monitor and predict changes in the rift. Satellite images and GPS technology allow real-time tracking of tectonic shifts and ground movements. Scientists can detect small movements in the Earth's surface, helping to confirm that the Somali and Nubian plates are moving apart. By studying magma movement and seismic activity, scientists can identify where new crust is forming, particularly around active volcanic areas. Seismic networks track earthquake patterns, providing insight into underground activity. Depth profiling allows geologists to study magma chambers and fault zones, helping to predict eruptions and understand the relationship between tectonic forces and volcanic activity. Advanced modeling and simulations are used to predict how the rift will evolve, such as when it will transition from a continental valley to a fully submerged ocean. These models can show how new volcanic systems will form and how the rift's crust will thin over time. What do you think about this new terrifying ocean in Africa? Share your thoughts with us in the comments section. Don't forget to like and subscribe.